10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of Falcon's first East Coast polar launch, Ola, Argentina.
We're now 40 seconds into flight. Falcon 9 has taken off. It's cleared the tower, and we're currently throttling down to prepare for maximum Q. That's the point of maximum aerodynamic pressure. It's at 1 minute, 12 seconds.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure.
You've heard it. We've reached max Q. At this point, the loads in the vehicle become less and less as the atmosphere gets thinner. We're now able to throttle those Merlin engines back up. And at its maximum power, like right now, the vehicle consumes more than 700 gallons of fuel per second. All's looking good with our first stage's trajectory. The next couple events, there are 5 events, one after another. First, our main engine cuts off on our first stage. The stages will separate. Our first stage will then flip around to begin its landing attempt. The second stage's Merlin vacuum engine will ignite for second engine start 1. The first stage's boost back burn will start. It's one of 3 burns to help us land. They occur one after another in about 15 seconds. And this is that first polar orbit. If the clouds, you can see through the clouds here, you'll see some unique views that you haven't seen from Falcon 9 over Florida.
And we have Miko.
Stage separation confirmed.
And ignition.
All right, all of those events happen successfully one after another. This boost back burn, it'll last about 40 seconds. And so you see it on the left-hand side of the screen. On the right-hand side, you will see our second stage carrying those 3 satellites to orbit. And coming up next in about 20 seconds, that boost back burn will end, and then we'll have our fairing deployment.
Stage 1 boost back shutdown.
All right, one of those first landing burn, the boost back burns has successfully ended. Our 2 fairing halves will now jettison to expose the satellites to space. And you see the first stage is already beginning to turn around, and you can see the nitrogen from our attitude control system helping guide it back.
Fairing separation confirmed.
There you see our 2 fairing halves have jettisoned. You can even see them in the background there on our MVAC engine, and you can see them from land too. It'll take us some time to get those to come back down. We'll keep you posted on the update.
We are T plus 4 minutes and 13 seconds into flight. Everything is looking great for tonight's mission. On the right-hand side of your screen is a view of our second stage, specifically its Merlin vacuum engine. We also call it MVAC engine for short. It's currently in the first of its 2 planned, first and only planned MVAC burn. The first burn should last for about another 4 minutes. On the left-hand side of your screen is a view of our first stage looking downward. It's continuing to fall back towards Earth. The next milestone for the first stage is its first stage entry burn. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere. Without this second burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket. That entry burn is coming up at T plus 6 minutes and 10
Second stage
seconds.
is following nominal trajectory.
Acquisition of signal, South Texas.
You may have also noticed that we've deployed our 4 hypersonic grid fins. Those are the honeycomb-like structures that you see on the left-hand side of your screen. They help to guide the first stage back during descent by moving the center of pressure on the vehicle. Again, those bursts of gas are nitrogen. It's absolutely normal, and those help to orient the rocket during its descent back towards Earth. And we're about 20 seconds away from our second burn, the entry burn.
Stage 2 FTS is safed.
Stage 1 entry burn startup.
And 3 Merlin engines have relit and are currently slowing the first stage down before it hits those dense parts of the atmosphere. Second stage on the right-hand side of your screen is continuing to perform as expected.
Stage 1 entry burn shut down.
And that is our second burn completed. And as we mentioned earlier, we are going to be attempting to recover this booster back at land on landing zone 1. The first stage has one more burn left.
Is saved.
That is the landing burn. It begins just before we
Second
touch
stage
down
still
and
following
provides the
nominal
booster with
trajectory.
a soft descent before we land. During this period, the landing legs will also be deploying. You might be able to catch it right before we touch down. They're stowed at the base of the vehicle and made up of state-of-the-art carbon fiber and aluminum honeycomb.
Stage 1 transonic.
You can see the cape getting closer and closer. What a cool view. The first stage is passing through the cloud layers right now.
Stage 1 landing burn startup.
And here comes Falcon 9 attempting its 4th landing.
Stage 1 landing leg deploy.
And you could not ask
Stage
for
1
a
landing
better
burn.
landing than that. Falcon 9 has landed once again. That is number 4 for this first stage booster and the 58th overall of an orbital class rocket. What a way to start off tonight's mission.
And we have Seco.
And the second stage Merlin vacuum engine has successfully had SECO 1.
Nominal orbit insertion.
And that is the other call out we were waiting to hear on. A good orbital insertion.
Well, welcome back from our mini coast phase. For those of you just joining us, we successfully launched our Falcon 9 rocket from Cape Canaveral on a polar orbit trajectory. We had a successful stage separation, a successful land landing, the 4th landing for this booster, and we're waiting the deployment of the SALCOM 1B satellite. It's just about 10 seconds, 15 seconds away. It's the second and final satellite in this constellation. We first launched its sister satellite, SALCOM 1A, in the fall of 2018.
SALCOM separation confirmed.
All right, you've seen it. We heard it. Successful deployment of that SALCOM 1B satellite. And as a reminder, this satellite and SALCOM 1A's satellite's goal is to gather soil moisture. It helps increase the productivity and competitiveness of the agriculture sector. It helps us generate risk maps that can help control crop disease. It helps implement better fertilizer systems and provide early flood warnings.
Stage 2 lock flow is closed out.
Beautiful shot of pad 39A with the crew tower to the next of it, not using that today. Coming up shortly here, we'll actually see some venting from that large truss structure on the left-hand side of the vehicle. You can see it starting there. That truss structure is what we refer to as the transporter erector. That's what rolled out Falcon 9 to the pad and provides electrical power as well as the propellants that we've been loading into the vehicle. At this point, we're just venting out liquid oxygen that is in the lines on the transporter erector before transitioning into the final steps before liftoff.
Falcon 9 is in startup.
So with that call out, Falcon 9 is now on autonomous internal control. Coming up, we'll hear from the launch director, see if they will give their final go for launch.
LD is go for launch.
So with that, Falcon 9 teams ready to go, vehicle ready to go, weather and range ready to support. Why don't we listen in to these final 30 seconds of terminal count.
T-minus 30 seconds.
Stage 1 flight press.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
We're pitching downrange.
Stage 1 propulsion is nominal.
T plus 40 seconds, Falcon 9 successfully lifting off from launch pad 39A at the Kennedy Space Center in Florida. We're taking that Starlink orbit to its first, Starlink satellites to its first targeted orbit and eventually a circular orbit. We actually just throttled down for maximum dynamic pressure, or max Q, on those 9 Merlin engines. We'll expect to hear that call out here shortly.
Vehicle is supersonic. Max Q.
So call out there for having gone through the point of maximum aerodynamic pressure. That's when the loads on the vehicle are the highest from the combination of our velocity, but increasing while the density of the atmosphere decreases. Now, coming up in just about a minute, we will have 3 events happening back to back. First will be main engine cutoff, or MECO. That's where we'll shut down those 9 Merlin engines. You can see the plume expanding from them on the back of the rocket here. That'll be in preparation
And back
for
engine
stage
tail has begun.
separation. Now, stage separation is where the first and second stages will separate. First stage will continue on a parabolic trajectory towards the drone ship, while the second stage continues on to the final event, or second engine start number 1. That's where that Merlin vacuum engine will ignite. And once it lights up, it'll propel the second stage along with Starlink satellites into orbit. Actually heard earlier that we've started chill in on the turbo pumps of the Merlin vacuum engine to get it ready for that full flow of propellant and oxidizer. So coming up just about 12 seconds from now, expect to see MECO, its main engine cutoff, then stage separation, and then at about T plus 2 minutes and 45 seconds, second engine start number 1.
MECO.
Stage separation confirmed.
So there is successful stage separation and second engine start. You can see the grid fins deploying on the left-hand side of your screen. That's the first stage. On the right-hand side of your screen is the Merlin vacuum engine starting to glow brightly with the heat of that combustion reaction. First stage making its way back towards
Acquisition of
planet
signal,
Earth.
Maryland.
Coming up here should be fairing deployment shortly.
Separation confirmed.
There's a call out on the nets and a beautiful shot of the Starlink satellites. You can see on the right-hand side there a little bit of planet Earth. And actually, you can see a fairing half there trailing away. Now, as a reminder, we will be attempting to recover both the fairing halves today on our recovery ships, Mystery and Mischief, that are also stationed in the Atlantic Ocean. Second stage heading towards its targeted drop-off orbit. Now, while that's happening, the first stage is actually going to execute 2 burns to make its way back to Earth. You can see right now that we are actually pitching the first stage vehicle to try to get those Merlin engines facing towards the atmosphere.
Signal Bermuda.
Those periodic gas clouds that you see along the first stage are actually from our attitude control system. And once we get to the top of the Earth's atmosphere, we'll ignite 3 of the 9 Merlin engines for entry burn. That'll help slow down the first stage as it re-enters the upper parts of the Earth's atmosphere. And the second of those burns will actually happen much closer to touchdown on the drone ship. That's the landing burn, where we will ignite just a single Merlin engine at the center of the set of 9. And that'll slow down the vehicle rapidly before hopefully a soft touchdown on our drone ship. On the right-hand side of your screen, continuing to see the Merlin vacuum engine continuing to burn. This is a pretty long burn for the Merlin vacuum engine. This will be going until about T plus 8 minutes
Second stage on
and 48 seconds. Call out there from the navigation officer that the second stage is on a nominal trajectory at this point. So flying right down the middle of the bars. Cool shot from the interstage on the left-hand side of your screen that's looking up at where the second stage previously was, looking out towards space, because those Merlin engines are pointed towards planet Earth. Coming up in about a minute from now, we'll expect to see that entry burn start. Entry burn expected to last about 20 seconds. Again, that'll be 3 Merlin engines, and usually you can actually see the plume sort of creeping up the side of the rocket, since the vehicle is right now both going thousands of miles an hour. At this point, the first stage has reached the highest point of its orbit, the apogee, so it is on the downhill portion of its trajectory. You can see Earth getting bigger and bigger.
Stage 1 FTS is saved.
Stage 1 entry burn startup.
Startup of those 3 Merlin 1D engines on the first stage. Second stage continuing to burn nominally.
Expected loss of signal, Cape.
Stage 1, entry burn, shutdown.
So with that, we will continue on the first stage to apply some attitude control from those attitude control thrusters. And as the atmosphere gets thicker and thicker, the grid fins will actually start to gain most of the control authority.
Second stage on nominal trajectory.
And the grid fins will continue to fly Falcon 9 in, giving us aerodynamic control. Looks like we just lost the link as it re-enters there. Here's a shot of the drone ship. Again, that's 624 kilometers off the east coast of Florida, awaiting first stage for a landing attempt. Second stage continuing to look good. That glow that you see on the nozzle extension is normal. That's just from the heat of the combustion reaction radiating out to space through the nozzle. Now, part of the reason why the second stage has such a large nozzle is to try to get the most out of the propulsive gases that we're producing in the propulsion chamber. And so that allows the second stage to be a little more efficient in the vacuum of space. Coming up here, we expect to hear a call out for landing burn start on the first stage. That'll be just a single center Merlin engine.
Landing burn, start up.
Shortly after, we'll expect to see landing leg deploy, and then hopefully a touchdown on the drone ship.
Terminal guidance.
Stage 1, landing leg deploy.
Looks like right in the center. That marks 61 successful recoveries. Third time for this booster. Now, coming up about 8 seconds from now, second stage is also going to shut down its engine for second engine cutoff number 1. Keep an eye out for that on the right-hand side of your screen.
Seco 1.
And successful shutdown of the Merlin vacuum engine navigation.
MVAC burn 2. And good shutdown.
So that's the third landing for that booster, 61st overall recovery. And we actually caught a fairing half today as well. That's the active fairing half. And this fairing half has flown 3 times, landed it right square in the middle of the net. We did have to abort the catch attempt on the passive half, but we're in the process of recovering that from the water on our other recovery vessel. Expect to see payload deployment.
Starlink deployed, confirmed.
So you can see the Starlink satellites gently floating away from the second stage. Now, shortly they will, once they've had a chance to space out a little bit, they'll deploy their solar arrays, and over the next few days and weeks, they'll start to distance themselves out using their onboard ion thrusters to make their way to their final operational orbits, about 550 kilometers above the Earth's surface. So happy to see them off and on their way to complete their mission. And with that, it's actually going to bring our webcast coverage to a close. We want to give a big thanks to the Range and the Federal Aviation Administration for supporting today's mission. If you're interested in getting future news about Starlink, head on over to starlink.com and sign up for updates. With that, we hope you have a wonderful rest of the day and a happy end to Scrubtober.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicles pitching downrange.
Stage 1, chamber pressures are nominal.
39 has successfully lifted off from Pad 39A at Kennedy Space Center, carrying our Starlink payload to its targeted drop-off orbit. Moments ago, we've begun to throttle down our engines on the first stage in preparation for Max Q. Max Q is where the vehicle will experience the highest amount of aerodynamic pressure.
Max Q.
And we've just passed Max Q. In a couple of minutes, we'll have 3 events happening back to back. First is main engine cutoff, also known as MECO. This is where all 9 Merlin engines on the first stage will shut down to slow the vehicle down in preparation for stage separation. Stage separation is where the first and second stage will separate from one another, with the first stage making its way back towards Earth for landing, while the second stage continues its journey with the third event, which is second engine start 1, also known as SES-1. This is where the single engine on the second stage, our Merlin vacuum engine, lights up and will continue to propel the second stage along with the Starlink satellites to orbit. We're about 25 seconds away from main engine cutoff. Got some really cool footage of Falcon 9 right now.
Stage separation confirmed.
All right, we had successful main engine cutoff, stage separation, and our second stage engine is now up on power on the right-hand side of your screen. Again, on the left-hand side of the screen is our first stage. It's going to make its way back to Earth to attempt landing for the 6th time on our drone ship in the Atlantic Ocean. Next event coming up is fairing deploy. It should happen just a few seconds from now.
Fairing separation confirmed.
And off goes those fairing halves, and now exposing the 60 Starlink satellites to space. As a reminder, we will be attempting to recover the fairing halves today using our recovery ships Miss Tree and Miss Chief. We'll make the call about 2 minutes before they land, depending on the weather and the sea states. We're just over T+4 minutes to flight, and as the second stage heads towards its targeted drop-off orbit, the first stage will execute 2 burns in order to make its way back towards Earth. The first stage is what you see on the left-hand side of your screen. The first is the entry burn, where 3 of the Merlin engines will reignite. This helps to slow the stage down as it re-enters the upper parts of the Earth's atmosphere. The second burn is the landing burn. This is a single engine burn that brings the vehicle speed down rapidly in order to land on the drone ship. The first burn, the entry burn, should happen around the T+6 minute and 20 second mark, while the second burn will happen around the T+8 minute mark. You can also see that our hypersonic grid fins have deployed on the first stage. Those are the honeycomb-like structures that you see on screen.
Vehicles on a nominal trajectory.
They help to guide and steer the first stage back during descent. Now, the satellites on the second stage, we're sending 60 more up there to join the existing 750. So after today's mission, we'll have 800 Starlink satellites up there. The satellites will stay powered down until after stage separation, until after they separate from the second stage. You might be able to see some periodic bursts of gas from the first stage. That is nitrogen gas from our attitude control systems. Those help to orient the rocket as it continues to fall back towards Earth. And we're just about 20 seconds away from the first of 2 burns, first stage entry burn.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
3 Merlin engines have relit and are now slowing the first stage down before they hit the upper parts of the Earth's atmosphere. I have a few more seconds left on this burn.
Stage 1 entry burn shutdown.
All right, the second burn will be happening about 90 seconds from now. Everything's looking great on our second stage. The view is of the Merlin vacuum engine and its thrust cone. That engine can produce over 220,000 pounds of thrust in a vacuum. We're about 30 seconds away from the beginning of our second and final burn. During this burn, the 4 landing legs stowed at the base of the first stage will also deploy right before we land. This final burn should last about 22 seconds. Let's see if we can land this first stage for the 6th time.
Stage 1 landing burn.
Terminal guidance.
There's a view of our
Stage
drone
1
ship.
landing leg deploy.
And right down the middle, Falcon 9 has landed. This particular booster has landed for the 6th time. This marks our 62nd successful recovery of a Falcon 9 first stage, and the 32nd time we've landed on this particular drone ship. Of course, I still love you. Great way to start off a Sunday. So now for the second stage, we're waiting for second engine cutoff before entering a coast phase.
Eco confirmed.
Expected loss of signal, Cape.
Restart ignition confirmed.
Starlink deploy confirmed.
And now you can see on screen these satellites are slowly separating from the second stage. Shortly they will deploy their solar arrays, and over the next few weeks distance themselves from one another and use their onboard ion thrusters to make their way to their operational orbit. That's a very cool shot. Quick update on fairing catches. It looks like we had a good catch on both fairing halves, but the corner of the net on Mystery didn't hold up and gave way. We didn't have any impacts to the recovery team personnel, so we'll bring them back and see if we can use them on a future flight. And with that, we'll be bringing our webcast to a close. Thank you to the Range and Federal Aviation Administration for supporting today's mission. Again, if you are interested in getting future news about our Starlink service, head on over to starlink.com and sign up for updates. Thanks for tuning in, and have a great
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And we have liftoff.
Vehicle's pitching downrange.
Propulsion is nominal.
At T plus 40 seconds into liftoff, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Air Force Station, carrying our Starlink payload out into space. Now, we just throttled down the engines in preparation for Max Q, which stands for maximum aerodynamic pressure. This is the largest structural load that the vehicle will see throughout ascent. Should be coming up on Max Q in a few seconds here.
Max Q.
And there's that call out that we just passed through Max Q. In about a minute, we will have 3 events that happen very quickly, one after another. That will be MECO, or main engine cutoff, stage separation, and SES1, or second engine start 1. And main engine cutoff is where all 9 of those M1D engines shut down to slow the vehicle down in preparation for stage separation, which is when the first stage separates from the second stage. After stage separation is SES1, or second engine start 1. And this is where the MVAC engine lights up for its first burn and propels the second stage along with the Starlink satellites to orbit. And at T plus 2 minutes, we are about 30 seconds away from those 3 events. Again, that's MECO, stage separation, and SES1. Again, it's SES1 because we do have 2 burns of the Merlin vacuum engine on today's mission. We have a beautiful view of the first stage.
Stage separation confirmed.
And there you just watched MECO, main engine cutoff, stage separation, and that second stage engine ignite. We're just about 15 seconds here from fairing deploy, and on your right-hand screen you can see a view of inside of those fairing halves, looking at the Starlink payload as well. And on your left-hand screen is first stage, making its way back to Earth.
Fairing separation confirmed.
And there, as you watch on your screen, that is confirmation that those fairing halves have deployed. And as a reminder, we will be attempting to pick up the fairing halves after they touch down on the water with our recovery vessel, Miss Chief, today. Now, with stage 2 well on its way to orbit, stage 1 is now heading back to Earth and will perform 2 burns on its way down.
Acquisition of signal Bermuda.
The first is the entry burn to assist in slowing the vehicle down as it passes back into the Earth's atmosphere. This will be a 3-engine burn, starting off with the center E9 engine and followed not too long after by 2 additional engines reigniting. Then the second and final burn for the first stage will be the landing burn, which is just a single E9 engine, and that is enough to rapidly slow down the vehicle to allow it to touch down on its landing zone. And again, for today, the landing zone is just read the instructions, which is currently out in the middle of the ocean waiting for this booster to come back. Stage 2 is looking good and nominal. Got a nice view of that MVAC engine on your right-hand screen. Stage 2 is taking our Starlink payload to its targeted orbit, and these 60 Starlink satellites will join the constellation already on orbit, which is which are designed to provide high-speed, low-latency internet to people here on Earth, and especially to places where good internet is really hard to access. It's just after T plus 5 minutes, so we're just about a minute away from the entry burn beginning on the first stage. Entry burn will be...
Trajectory.
There's a call out. The vehicle second stage is on nominal trajectory. That entry burn will last about 22 seconds long. And you can see on your left-hand screen the first stage, the grid fins are deployed, but they actually don't start steering until after entry burn. That's because it requires the atmosphere and air to be flowing through those grid fins. Got some really awesome clear views on both the first and second stage. You can see Earth in the background. We're just about 15 seconds or so away from that entry burn on the first stage.
Stage 1 FTS is saved.
Stage 1 entry burn start.
And there you can see the entry burn has begun. And as you saw, the plume started out small and then got larger, and that's because we light up the first single engine and then followed by 2 additional engines on this entry burn for a total of 3.
Stage 1 entry burn shut down.
And entry burn is now complete. As you see, those engines have shut down. So next up, in about a minute or so, will be that landing burn for the first stage. And as I mentioned earlier, it will just be the center.
Follow nominal trajectories.
It will just be the center E9 engine for the landing burn, and that's enough thrust to slow the vehicle down. The M1D engines have 845 kilonewtons, or 190,000 pounds of thrust. Again, that's enough to slow this very large vehicle down to touch down on that drone ship that you see right there in front of you. That's just read the instructions. And this will be the 3rd landing for this specific booster. About 20 seconds or so away from that landing burn beginning. It was a very clear and beautiful day over there in Florida, so hopefully we get a nice, beautiful view of first stage landing.
Stage 1 landing burn.
There's confirmation, stage 1 landing burn. You can kind of see that burn kind of shaking the camera there.
Stage 1 landing leg deploy.
Seco.
Stage 1 landing confirmed.
And we had a little bit of a rough camera view there, but the Falcon has landed on our drone ship for its 3rd landing on Just Read the Instructions. This marks our 63rd successful recovery of a Falcon first stage and the 11th for Just Read the Instructions. And looks amazing as we can see it there now, standing stably there.
Lost the signal, Cape.
And now we're waiting on your right-hand screen for SECO 1, which is second engine cutoff 1. There's that call out for SECO. Now we're waiting for confirmation of good orbit. Oh, there it is. Green, that is the stack of 60 Starlink satellites right there in front of us. It looks like we're getting a little glare from the sun there as well. That is because the second stage is rotating a little bit on its central axis to give the satellites momentum as they deploy. You can actually see the peak of the
Starlink
sunlight.
deploy confirmed.
And there you could see on your screen the stack of 60 Starlink satellites have successfully deployed from second stage. And what an awesome view with the sunlight hitting those Starlink satellites. And right there, we just watched the final deployment for SpaceX's 100th successful mission. How exciting and what an incredible milestone to reach. What an awesome view as well. The Starlink satellites will soon deploy their single solar array, and over the course of a few weeks, they will distance themselves from each other and use their onboard ion thrusters powered by Krypton to make their way to their operational orbit. And that brings our webcast to a close. As a reminder, today's launch marks SpaceX's 100th successful flight of a Falcon rocket since Falcon 1 first flew to orbit in 2008. To date, SpaceX has landed Falcon's first stage rocket booster 63 times and reflown boosters 45 times.
Good evening from the webcast desk here at SpaceX headquarters in Hawthorne, California. I'm John Innsbrucker, Falcon 9 Principal Integration Engineer. It's been a quiet countdown during the day, working relatively few minor issues. The teams are ready to launch as we approach T-minus 8 minutes to liftoff. Now we're launching from Space Launch Complex 40 here in the dark of Cape Canaveral. This will be our third GPS launch, and all of them have been from this launch pad. Now the spacecraft team performed functional checkouts of the GPS satellite during the day, and the Falcon 9 team began their final checks of the launch vehicle at T-minus 2 hours. At T-minus 38 minutes, the team concluded their electronic go-no-go poll and gave the okay to proceed into propellant load and launch. The team then began loading propellant at T-minus 35 minutes. We load the propellants as close to launch as possible in order to keep them cold. Both the first and second stages use the same propellants, as the second stage Merlin engine is very similar to those on the first stage. This allows us to make the second stage like a shorter version of the first stage, and this commonality is one of the many reliability features in the Falcon design. Now our fuel is a refined form of kerosene known as RP1. Our oxidizer is super chilled liquid oxygen called LOX. I mentioned keeping the propellants cold. We chill the liquid oxygen as cold as we can get it, allowing us to load more into the booster. Now currently the second stage is fully loaded with RP1 fuel, and the first stage continues loading for another minute. Liquid oxygen is also loading on both the first and second stages right now. Next activity, we're waiting for the call out that Falcon 9 is in startup.
Falcon 9's in startup.
There it is. Computers have taken over the Falcon 9. We're pressurizing first and second stage tanks for launch. Waiting for final go.
The mission director,
Stage
go
2,
for launch.
for flight.
Mission director has given the go for flight. Everything continues to look good. Pressurizing the tanks one final time here to get ready for liftoff. But right now at T-minus 30 seconds and counting, all systems are go for the launch of Falcon 9 with GPS 3, space vehicle number 4.
T-minus 15 seconds.
Falcon 9's configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Go Falcon, go GPS.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
"30 seconds into flight, propulsion says the Merlin 1B engines are nominal. We're on trajectory and preparing to throttle down in preparation for maximum dynamic pressure." And we're heading into the throttle bucket as we power down the Merlin engines. And throttling back up now. M1D engines back up at full power.
Supersonic.
And we have gone past Mach 1. Waiting now for Max Q call out.
The vehicle is experiencing maximum aerodynamic pressure.
Guidance engineer reports we're passing through the period of maximum aerodynamic pressure called Max Q. From here on, as the speed picks up, the atmospheric density decreases and the loads are reduced on the Falcon 9 vehicle. Propulsion power continues to look good. The trajectory looks good.
MVAC engine chill started.
The engine chill in call out on the MVAC second stage engine indicates we've begun chilling that turbopump like we did with the first stage engines, getting ready for ignition of the upper stage engine. Now coming up in just over 30 seconds, the usual 3-sequence event that'll happen in rapid succession. Main engine cutoff will shut down the 9 Merlin 1D engines you can see glowing there in the night sky. Stage separation, and then we'll get startup of the second stage engine. Nice view from the ground camera looking up at the 9 Merlin 1D engines on the business end of the Falcon 9 first stage.
Stage separation confirmed.
And VAC startup.
So we've had a good separation. MVAC up on power. On the left screen, the first stage continuing to coast downrange as it begins to deploy those large titanium grid fins. Trajectory continues to look right down the middle.
Both stages are following nominal trajectories.
Guidance confirms we're on nominal trajectory with both stages.
Acquisition of signal, Maryland.
Maryland reports they've got signal from the second stage. Next event coming up is payload fairing separation.
Fairing separation confirmed.
A nice view from the camera looking forward. The GPS-3 satellite with the 2 payload fairing halves separating. Everything continuing to go well on this mission. 3 minutes and 42 seconds into flight. First stage continuing to coast to apogee, headed downrange. Second stage engine at full power. Everything's looking good with the MVAC engine. Right now, trajectory heading us to where the Bermuda ground station. Can hear us? We've heard the call out, acquisition of signal. Bermuda now getting the telemetry from the Falcon 9 second stage. So 4 minutes, 8 seconds into flight, everything going well on the flight of Falcon 9 with GPS-3.
Both stages continue to follow nominal trajectories.
And at T plus 4 minutes and 20 seconds, we're currently in the first of 2 planned MVAC burns. And we just passed T plus 4 minutes and 23 seconds, and that's actually when the first stage reaches apogee of 120 kilometers, almost 400,000 feet. At stage separation, the first stage velocity is about 2,200 meters per second, or 5,000 miles per hour. So right after stage separation, the first stage, still moving at such a high velocity, continues to raise its altitude as it coasts for a couple of minutes. Basically, the first stage almost doubles its altitude from stage separation, which occurred at about 69 kilometers or 226,000 feet, to when it reaches apogee, and then it starts its return back to Earth. And again, apogee is the highest point, or the furthest that it is away from Earth in the trajectory of the first stage. Now, the next major milestone that you'll be able to see on your screen is the first stage's entry burn. For the entry burn, we relight the center E9 engine, and then partway through, we relight the E1 and E5 engines so that we have a total of 3 M1D engines, helping to slow the vehicle down as it passes back into the Earth's atmosphere. We're just about 40 seconds away from that entry burn beginning. Today's entry burn should last about 27 seconds long.
Both stages continue to follow nominal trajectories.
And you heard that call out that both stages are looking good. T plus 6 minutes. We're about 20 seconds away from that entry burn on first stage. And it is nighttime over there on the East Coast, so hard to see that first stage on the left-hand screen, but once entry burn begins, it should light up that screen. We should be able to see first stage pretty well.
Stage 1 entry burn startup.
And there's that entry burn starting up.
Stage FTS is saved. Stage 1.
You could see the plume started off small and it got a little larger, and that is because we started with one single engine and added a couple engines for a total of 3 for this entry burn.
Stage 1 entry burn shut down.
And that concludes the entry burn. Next up, we do have a couple major milestones happening back to back. The start of the landing burn for first stage, followed immediately afterwards by SECO-1 on second stage. And SECO, which stands for second engine cutoff, is where we shut down the MVAC engine to allow the second stage to coast, which preserves the fuel until we need it for the final burn to take us to our targeted orbit for the GPS-3 satellite. Then about 25 seconds.
Cape, stage 1 expected.
Then about 25 seconds after SECO-1, we'll hopefully have a nice view of the first stage touching down on, of course, I Still Love You. And there's that drone ship on your left-hand screen.
Stage 2 has entered terminal guidance.
Stage 1 transonic.
Just about 20 seconds away from those two events. Again, the landing burn, followed by SECO-1 on second stage, just a couple seconds after that landing burn begins.
Stage 2 FTS is saved.
Stage 1 landing burn.
And SECO.
And there we've had SECO waiting for confirmation of good orbit as first stage returns to Earth.
Stage 1 landing leg deploy.
Nominal parking orbit.
There's good orbit, and at the same time, we have touchdown of our Falcon 9 on, of course, I Still Love You. And again, that did happen at the same time, so we did have SECO and good orbit of our second stage.
2 expected.
And there you can see on your left-hand screen, first stage landed on, of course, I Still Love You. This marks the 16th Falcon 9 landing just this year and the 64th of all time. And we're looking forward to seeing this booster take its second flight on the next GPS mission next year.
Coming up on the second burn of the upper stage engine in about half a minute. Flight computer is currently commanding settling thrusters to turn on and off. That's releasing nitrogen gas out of 2 thrusters in the back of the second stage that lightly pushes the stage, and that helps keep the propellant at the bottom of the tank right above the inlets to the engine's turbo pumps. As you can see from the ground track, we're passing south of the Tasmania ground station in Australia. Following the burn, we'll be headed in orbit up towards the Hawaii and Vandenberg ground stations, awaiting for ignition.
MVAC ignition.
We've got ignition of the second stage engine. We're up on power. Now, the second stage will burn for 45 seconds. We're going to be adding over 2,000 meters per second to the speed of Falcon 9 before we shut it down for the second time. You can see from the velocity meter on the screen, the speed clicking up. We're still at 419 kilometers in the same altitude in the parking orbit where we've been for a while. But this burn is going to bring us all the way up into the transfer orbit, and then shortly after that, we'll separate the GPS satellite. Now we're coming up on shutdown number 2 called SECO-2, and this is the burn that will place GPS-3 space vehicle into the required orbit.
MVAC shutdown.
We've got SECO, MVAC shutdown call out. We're waiting for the orbit.
Nominal insertion orbit.
The guidance, navigation, and control engineer has called out a nominal orbit. Looking at the data, it's an excellent looking orbit. So second stage in a good orbit. GPS spacecraft is still attached to the Falcon 9 at this time. Now we're going to go through a series of events to get ready for separation. A little bit after we have finished a short coast, we are going to start a slow spin of the second stage. That's going to help stabilize the GPS satellite when it's released from the second stage. We also have to wait until the orbit takes us into range of the 2 Air Force satellite ground stations, one in Hawaii, one in California. We've got to make sure that the ground stations can be in contact with the GPS satellite before we release it. So all of this is going to take 24 minutes to get into the right situation at the right spin rate. And that satellite separation is planned to occur at about T+1 hour and 29 minutes. So we're going to...
John mentioned earlier that are necessary to connect to prior to deployment today. We've got a nice live view of that GPS-3 satellite.
Payload deploy confirmed.
And there confirms the deployment of the GPS-3 satellite as it's drifting away from Falcon 9 with a nice sunlit view there. This confirms a successful spacecraft separation, and that completes our primary mission, which will bring today's webcast coverage to a close.
And it's a great view of the GPS satellite drifting slowly away from the Falcon 9 second stage, and it's a great way to bring a webcast to an end. We'd like to thank the U.S. Space Force for entrusting us with today's GPS-3 Space Vehicle 4 mission. Now, we look forward to the additional GPS missions we will be supporting in the future. Special thanks this evening to the 45th Space Wing for range support, and to all of our viewers, thanks for joining us for today's mission, and have a good weekend.
On board, but all of the NASA and SpaceX employees
Firing forward.
crew team member. This is a military test flight expect having a blast with it.
I was since before and those since and those that are going to come will enable research that's going to continue seamlessly on the International Space Station as NASA moves forward and beyond.
They should be making their way out of the room momentarily. They probably just a few moments ago finished up playing the mysterious Starship. Nicole knows about this. The Crew-1 astronauts now beginning their journey to the launch pad ahead of this historic mission to the ambient conversations
Okay, right on time, and a great view of Dragon sitting on top of the Falcon 9 as we're continuing to load liquid oxygen onto both the first and second stages. The RP-1 kerosene fuel.
And Falcon 9 is in startup.
Can I get a countdown? FTS is armed, Falcon 9 is in startup and is now controlling.
50 seconds now until liftoff. That FTS you heard is flight termination.
Dragon, SpaceX, go for launch.
SpaceX, this is Resilient. Roger, go.
Go for launch, and at 37 seconds, the International Space Station flying over Kennedy Space Center.
All for one, Crew-1 for all.
Crew Dragon poised to go catch it. 20 seconds till liftoff.
T-minus 15 seconds. Falcon 9 is configured for flight. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And resilience rises. Not even gravity contains humanity when we explore as one for all.
M1E propulsion is nominal.
That's the word we want to hear. Stage 1 propulsion is nominal.
As 30 seconds into this historic mission, flying crew on board Dragon and Falcon 9. Stage 1 is preparing to throttle down. This is in preparation for max Q, which is maximum aerodynamic pressure.
Stage 1, throttle down.
There's that call out for throttle down.
Power and telemetry continue to be nominal for the vehicle, now traveling at 262 meters per second.
Falcon 9 is supersonic.
There's that call out. The Falcon 9 is supersonic, and we will be passing through max Q here shortly, the largest structural load during ascent.
Max Q.
There's that call out. That Falcon has passed through max Q.
1 Bravo.
And we've just entered Stage 1 Bravo abort mode. That's going to take them through the end of the first stage burning just before second stage activates off the coast of North Carolina. T plus 1 minute and 40 seconds into flight. Dragon and Falcon 9 traveling 709 meters per second. That call that MVAC chill is underway, the Merlin vacuum engine.
Now with the call out of MVAC de-chilling, similar to what we saw in the first stage Merlin engines, the second stage engine being prepared for its ignition coming up in just over 30 seconds from now. We're a half a minute away from 3 quick events in rapid succession. We're going to get main engine cut off. The 9 Merlin engines will throttle down and then shut down. We're going to get stage separation.
Stage 1, throttle down.
And then ignition of the second stage engine. We've begun the throttle down in preparation for stage separation.
And we have
2 Alpha.
Stage separation confirmed.
And you see that stage separation has confirmed. There goes that MVAC engine. Stage 2, Crew-1 is now on their way to the International Space Station. On the right side of your screen, you see Stage 2 continuing to burn. Over on the left-hand side is Stage 1 preparing for its return to Earth.
Currently on the left side, you can't make out much. It's a couple hours after sunset in Florida, but the grid fins have deployed on the first stage. The first stage is now unpowered, but with the velocity it had, it continues to coast up to an apogee before it begins to descend back into Earth's atmosphere. Now as we watch, maybe we'll see the lights of Florida or the eastern seaboard in the background, but otherwise there's not going to be much to see. On the right-hand side,
Dragon, SpaceX, trajectory nominal.
You can hear the call out. Trajectory is nominal.
Nominal trajectory.
And we've heard the call out Bermuda. That means Bermuda ground station has the signals from the second stage of the Dragon and Falcon 9.
We're still continuing as stage 2 burns to listen for those abort zones. We are now in 2A through 2E to Echo, taking us up over the northern Atlantic.
Right now you can see the second stage engine glowing with the standard red that we have come to see over all these missions. Indicates everything's looking good. Power on the MVAC-D engine continues to run at 220,000 pounds of thrust in the vacuum of outer space.
Dragon, SpaceX, trajectory nominal.
And trajectory nominal.
Copy, nominal trajectory.
And we hear the reply from the crew acknowledging we have a nominal trajectory. Dragon made it to the Falcon 9 second stage, heading into the low Earth orbit, where Dragon will then separate and begin its trip the rest of the way to the space station.
We'll be looking for SECO, second stage engine cutoff, coming up at 8 minutes and 48 seconds after launch today, so about 3.5 minutes from now. Dragon and Falcon 9, second stage, currently flying 2,979 meters per second.
Now currently the first stage has begun its descent. It is through apogee. It's beginning to come back down, where it coming up in another couple of minutes, we will have the entry burn, where we begin to slow down the first stage.
SpaceX, trajectory nominal.
Copy, nominal trajectory.
Another call out, another nominal trajectory, just what we love to hear.
That voice you're hearing on board Dragon, that's Commander Mike Hopkins, speaking for our 4-person crew as they continue their journey, now 6 minutes and 12 seconds after liftoff. Trajectory still nominal.
And Leah, you can see on the indicator altitude, 201 kilometers. We're now beginning to essentially level out and pick up velocity to get us into low Earth orbit. We're a little under 1 minute from the ignition for the entry burn on first stage.
And we're about 2 minutes away.
Dragon, SpaceX, trajectory nominal.
Copy, nominal trajectory.
Great news, now 7 minutes after launch. Second stage engine continues to burn, everything looking good. And we'll see that continue to burn for another 1 minute and about 38 seconds.
Right now on stage 2, the crew's getting about a little more than 2.5 G's of acceleration. First stage preparing to ignite for the entry burn.
Stage 2 FTS has saved.
And we've got ignition of the entry burn, center engine, followed by the other 2 restart engines. First stage now getting ready to re-enter the Earth's atmosphere. This is about a 29-second burn, and it's designed to slow the vehicle way down. We're going to shed about 70% of the velocity of that dropping first stage by the time this landing burn completes. I should say by the time the entry burn completes, which is now over. First stage on target for the drone ship in the Atlantic Ocean. Meanwhile, we're watching second stage getting close to getting into orbit.
That's right, we've got about 30 seconds
Stage 2 internal
more.
guidance.
And now just about 20 seconds more of stage 2 continuing to burn until we see second stage engine cutoff, or SECO. We'll coast for a few minutes afterward to allow the rates in motion
Shannon.
to
Roger,
there.
Shannon.
there's that call for Shannon. That's Shannon, Ireland, an abort zone, but it looks like we continue smoothly to orbit today.
MVAC shutdown.
And we've got shutdown of the second stage engine on time.
Dragon SpaceX, nominal orbit insertion.
Launch escape system is disarmed.
And SpaceX copies.
And Leah, the words we like to hear, a nominal orbit insertion.
That's right, John. Nominal orbit insertion, as we mentioned, stage 2. Oh, looks like some action on stage 1. And I believe we've had a touchdown on the drone ship.
We've got stage 1 has touched down on the drone ship in the Atlantic Ocean. But now the more important news, second stage is in orbit, right where we want, right on time. And we're getting ready for our next major activity, which will be Dragon spacecraft separation. Now, currently on the second stage, we are essentially venting pressure, purging the engine out, making sure everything is quiet in preparation.
Take a look. That's inside Crew Dragon right now. Our Crew-1 crew now coasting in low Earth orbit, still attached to that second stage. In just a couple of minutes, we should see that second stage separate and Crew Dragon will be flying free.
Leah, the mission timer shows 90 seconds to Dragon separation.
Currently, Dragon is flying at 27,000 kilometers an hour. And we're T+ 11 minutes since liftoff today, waiting on that second stage separation. But as you can see, our astronauts from left to right, Shannon Walker, Victor Glover, Mike Hopkins, and Soichi Noguchi, now on their way to the International Space Station. First trip to space for Victor Glover.
Acquisition of signal in Newfoundland.
And that call out, acquisition of signal in Newfoundland. That means the Newfoundland ground station is now receiving telemetry from Dragon. This view inside Mission Control Hawthorne. Teams continuing to monitor the vehicle, now traveling at almost 27,000 kilometers an hour.
Ten seconds to Dragon separation.
Dragon separation confirmed. And separation confirmed. You can see that second stage departing. Crew Dragon leaving it behind.
Separation confirmed.
Now 12 minutes, 25 seconds into today's flight. Our next thing we'll be looking for is nose cone deploy. Our hooks will start to open on the nose cone and reveal those forward thrusters underneath. Thirteen minutes into today's mission, the view on the right-hand side of your screen coming from Crew Dragon. We had that short look at the second stage as it departed. That second stage will burn up upon re-entry into Earth's atmosphere.
Dragon SpaceX, we see nominal service section Draco checkouts and the humidifier activation.
SpaceX, this is Dragon. We copy all and we see the same.
Confirmation from teams on the ground and the crew. You can see them monitoring those 3 display panels, monitoring their journey to the International Space Station and where they are in the world right now, or over the world, I should say.
Well, we're in 14 minutes, 25 seconds since it was a great liftoff. Everything happened. We had a nominal insertion into low Earth orbit. You saw Dragon separate. We got the Draco checkouts were good. And right now we're hearing the nose cone hooks are opening up. Everything is happening right per the procedure. And we've got Crew-1 successfully on orbit. So with that, let's head over to our counterparts at Kennedy Space Center. Marie, how was that launch for you all there on the ground?
Situated for it here on just the mouth of the Santa Ynez River, spilling into the Pacific Ocean. It is an incredible view. We are blessed indeed.
It is so beautiful. Now, there are teams on opposite ends of the world working on this mission. The satellite will be controlled from the European Space Agency's Operations Center in Darmstadt, Germany.
Yeah, and here at Vandenberg Air Force Base, SpaceX's launch team is working the countdown from their control room, while NASA's Launch Services Program, that you see right there, is at the Mission Directors Center just a few miles away. Now, shortly after Sentinel-6...
Upon arrival, it was unpacked in the safe confines of the clean room. A team of scientists, engineers, and technicians began the critical process of preparing the spacecraft for launch. Over the last few weeks, they have thoroughly tested and checked out all aspects of the spacecraft to ensure its readiness for flight. The next critical step, the integration of the spacecraft with the Falcon 9 launch vehicle. Sentinel-6 was carefully encapsulated inside the rocket. Yesterday, Sentinel-6 and the Falcon 9 rolled out of the SpaceX hangar.
We'll still be connected. There's that call. The retract has started. That strong back provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right. I'm definitely happy for the people out there in Southern California because, we get a million launches out here, but, if they can finally see some, especially at JPL, because it's, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. You kind of told us about the flight path, but what is this rocket capable of? There's a lot going on here.
Right, there's a lot going on, and we have some beautiful views of this Falcon 9. So you can see it's a 2-stage rocket. The first stage, or the booster, goes about 2/3 of the way up, and that actually provides 1.7 million pounds of thrust, which is going to get the vehicle and the spacecraft off of the pad. The second stage, its engine is housed in that black interstage region that's just below the 5-meter fairing, and that's what's going to finally bring the spacecraft up into its orbit. And as we've discussed already, that first stage, once it separates from the second stage, is going to head on back to Vandenberg.
Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear calls for flight through max Q, or maximum aerodynamic pressure, and then we'll about 2.5. strong record track has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel-6, Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal. M1D propulsion is nominal.
Power and telemetry nominal.
Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1 boost pack burn has started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an orange.
Vehicles are following nominal trajectories.
Bearing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost pack burn, shutdown.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second stage.
Vehicles continue to follow nominal trajectory.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Stage 1, entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It was incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2, and we're going to call that out Here it comes. There it is.
Wow. Oh my goodness.
Coming in at an angle.
Oh my God.
And just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness. I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down so perfectly.
perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my we heard that.
Oh, that was
And Falcon 9 has landed at LZ4. Landing operators
beautiful.
proceed into 11.100 on recovery 2.
I'm a little
The
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said,
Coast before the second burn.
So with the rocket, we bring all the gas with us. There's not gas stations in the way. So we want to try and use as little as possible. And so just the way that it works is that, you know, we start
Hey, Callie, I want to jump in there for
we
a
fly
second.
up in the early parts to a
We're
park.
looking at the spacecraft separation right now. I want to let you finish, but we're getting that live, and I wanted to call that out for you. So there goes Sentinel-6. That is a beautiful sight. Watching it drift off there. Again, we are kind of shaded by the Earth, so we're not in direct sunlight at this time. So that's why it's as dark as it is. If the sun were on this side of the Earth, we'd see a little bit more of that, but that's going to kind of just drift off, and that's completely normal and expected. So, Callie, I do want to let you finish. Sorry for jumping in there.
No, yeah, that's the part, exciting part when the rocket's done its job. So what we did was we got to a park orbit coast with the boost and the first burn. And so with that, we still had a perigee, so the point we're closest to the Earth, just above 160 miles. And so we were near that. And then we coast and just let physics do its job, where we go out to the furthest part, 800 miles.
Number 6, and you're looking at a live view of Falcon 9 on Launch Pad 39A at Kennedy Space Center, and we're about to launch a Dragon spacecraft. Liftoff is targeted at 11:17 a.m. Eastern Time. My name is Andy Tran, and I'm a production supervisor here at SpaceX. It's great to be here with you to cover our 21st commercial resupply mission to the International Space Station for NASA. On screen and on top of Falcon 9 is an upgraded version of our Dragon vehicle. We've seen this new vehicle fly people twice now. The first was on our Demonstration 2 mission earlier this year with NASA astronauts Bob Behnken and Doug Hurley, and most recently on the Crew-1 mission with the four NASA astronauts who are currently still living and working on the space station. For today's mission, instead of people, we'll be transporting cargo, and this will be the first flight of cargo in our upgraded Dragon. It's worth highlighting that all CRS flights going forward will fly from Pad 39A, and late cargo load will be done through the crew access arm. To this day, Dragon remains the only spacecraft currently flying that's capable of transporting significant amounts of cargo to and from the Earth. Once Dragon reaches its destination, it will be the first time that we have 2 Dragons docked at the orbiting laboratory at the same time. Between Crew Dragon and the cargo resupply missions, at this time, we are anticipating that there will be a Dragon spacecraft attached to the International Space Station at all times throughout 2021. And one final milestone to highlight today. If all goes according to plan, today's launch will mark the 100th successful mission for Falcon 9. So a lot of excitement ahead in the next hour. We are targeting an instantaneous launch window, currently at T-minus 13 minutes and counting, with all systems currently go at both our Kennedy Space Center and SpaceX Mission Control in Hawthorne, California. So with that, let's take a closer look at today's Falcon 9 and Dragon spacecraft. This is going to be SpaceX's 24th launch this year, and as I mentioned, this is the cargo configuration of our new Dragon spacecraft. This version of Dragon is designed for up to 5 flights, while the previous version of Dragon can only support 3. Dragon was also designed from the beginning to be reused, so we are hoping to refly this vehicle again in the future. To date, 9 of our CRS missions have launched flight-proven Dragons. Today, we'll be delivering approximately 6,400 pounds of cargo to the space station, including critical materials to support dozens of science and research investigations that will occur on board the orbiting laboratory. We'll go into a little bit more detail on some of that research later on in today's webcast. This version of Dragon has 20% more volume and double the powered lockers. And in order to fly more cargo, we've made a few modifications to the spacecraft from the vehicle used on our Demo 2 and Crew-1 missions. Since there are no people on board, we've removed the Super Draco engines, which not only power Crew Dragon, but will also carry astronauts away from Falcon 9 to safety in the unlikely event of an emergency on the pad or during ascent. We've also removed 2 trunk fins used only for abort scenarios, and in the pressurized section, the seats and crew displays have been swapped for cargo racks. Lastly, the environmental control systems has also been reduced in both size and complexity. And while this Dragon will be flying for the first time, the Falcon 9 first stage, which is the bottom 2/3 of the vehicle, is a flight-proven booster. Today's mission CRS-21 will be its 4th flight. It previously supported the Demo 2, Anasis 2, and most recently, the Starlink mission in October. To date, we've had 99 successful Falcon 9 launches. 42 of those were on reflown boosters. And today, we'll be attempting to recover the first stage on our drone ship, Of Course I Still Love You, stationed in the Atlantic Ocean. You can see it on screen right now. And for those keeping count, if we do successfully land Falcon 9 today, this will mark our 68th booster landing and the 35th successful landing for our drone ship, Of Course I Still Love You. And finally, above the first stage is our second stage. It has a single Merlin vacuum or MVAC engine, which ignites after the first stage separates. The second stage is what will carry Dragon to its intended orbit, allowing the spacecraft to eventually rendezvous with the International Space Station. It's T-minus 10 minutes. And 20 seconds and counting. The SpaceX team is working no significant issues. For propellant, the go, no-go poll was conducted at the T-minus 38-minute mark, and propellant loading began shortly after that, around the T-minus 35-minute mark. At this point, RP-1 fuel is completely loaded on the second stage and almost done on the first stage. For liquid oxygen, it's currently underway on both stages and should complete around the T-minus 2-minute mark. We're also loading helium gas into both stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks, as liquid oxygen and RP-1 are consumed by the Merlin engines during ascent. For Dragon, we've also began its startup sequence at the T-minus 35-minute mark when it coordinated timing with Falcon 9. It's currently undergoing vehicle health checks with the next big step just before liftoff when the Dragon transitions to internal battery power. The range is standing by and ready to support. As for weather, a bit better than yesterday. We're looking at a 40% probability of violation with the primary weather constraint of thick clouds. There may also be some precipitation in the thick clouds that we are monitoring and will continue to monitor all the way until T0. Other than that, with the launch team, Falcon 9, Dragon, and range reporting green, and at T-minus 9 minutes and counting, all systems are go for launch of CRS-21 today. To retract away from Falcon 9 in preparation for liftoff. In about a minute, around the T-minus 2-minute mark, liquid oxygen should complete loading on the second stage, and that will be the last of our propellant loading. At the T-minus 1-minute mark, Falcon 9 flight computers will enter startup mode and guide the rocket through the rest of the countdown. Shortly after that, the SpaceX launch director will give the go for launch, and finally at T0, the rocket is released from the hold down clamps for liftoff, after which the strong back fully retracts away from the rocket, clearing way for Falcon 9's ascent. Checkouts of the second stage thrust vector control actuators are also underway. You often hear people refer to this as an engine wiggle test. This is when we move the thrust nozzle slightly to make sure that the guidance hardware is a go for flight. We do the exact same checkouts on the engines for the first stage, except that occurs just seconds before ignition. Dragon is also performing its final health checkouts to make sure all of its primary systems are ready for its rendezvous with the space station. The range remains a go for launch, and whether we are still continuing to monitor. Let's listen into the nets for the last few minutes of terminal count. And you can see that we have some white clouds starting to form around Falcon 9. This is completely normal for us at this stage in the countdown. That is liquid oxygen condensing when it meets the warmer ambient airs of Florida. We've just passed the T-minus 1 minute mark. Both stages are beginning to pressurize for launch. And we are reaching the T-minus 30-second mark. All systems are go for launch. This is mission CRS-21, the last mission of Dragon for this year. T plus 50 seconds into flight. Falcon 9 is carrying our upgraded Dragon vehicle to low Earth orbit. In a few seconds, we'll be passing max Q, which is the moment where the vehicle will experience the highest amount of aerodynamic pressures. And we've just passed max Q. Coming up are 3 events in rapid succession. The first event is MECO, or main engine cutoff. This is where all 9 of the Merlin engines on the Falcon 9 first stage will shut down in preparation for the second event, which is stage separation. This is where the first and second stage will separate from one another. And a few seconds after that, we'll have a second engine start 1, where the Merlin vacuum engine on the second stage will ignite to boost Dragon to low Earth orbit. Again, that is main engine cutoff, stage separation, followed by second engine start on the second stage. Main engine cutoff should happen around the T plus 2 minute and 31 second mark. And you just saw on screen successful main engine cutoff, stage separation, and ignition of our second stage. So on screen right now, you have 2 different views. On the right-hand side is a view of our second stage Merlin vacuum engine. On top of that second stage is our Dragon vehicle. And on the left-hand side is a view from the top of our first stage looking downward. The first stage will continue its descent back towards Earth and attempt landing on our drone ship, Of Course I Still Love You, in a few minutes. while the second stage continues to take our Dragon vehicle to low Earth orbit. If you are just joining us, this is the 21st commercial resupply mission for the International Space Station for NASA. This is also SpaceX's 24th launch this year. And we're flying a cargo configuration of our new Dragon spacecraft. Now looking on the left-hand side of your screen, the first stage, in order to make its way back to our drone ship, the first stage executes a series of 2 burns. The first burn is the entry burn, where 3 of the Merlin engines will reignite. This helps to slow the stage down as it re-enters the upper parts of the Earth's atmosphere. The second and final burn is the landing burn. This is a single engine burn that brings the vehicle speed down rapidly in order to land on our drone ship. The first of those 2 burns, the stage 1 entry burn, should happen around the T plus 6.5 minute mark. Until then, we get some really cool views of both the first and second stage. You notice that our grid fins on the first stage have also deployed. Those help to guide the first stage back during descent.